I'm not normally a developer for any of the major distributions. I am here to talk about distribution for scientific software that I started working on because of my experience with the open source mathematics package called Sage. This is a big, software distribution in one sense, and a Python mathematics library, which relies on a lot of open source mathematics packages to create an alternative to large computer algebra systems like Mathematica, Maple, and MATLAB. Maybe you've heard of these things. I should first ask how many people are, I don't know, distribution developers? Okay, scientists who work with software? Okay, so this will be mainly for the, for the benefit of the scientists. I, of course, included some technical details to explain what is underlying. As you can see, it is powered by Gentoo, so this actually is quite a bit, I don't know, an advertisement for Gentoo as well. I'll start with the motivation. So sometime last year, I received this email from a senior mathematician, and he wanted to do some computation, and it was something quite simple. He just wanted to compute the rank of a matrix. This was it. But the matrices were getting kind of big, and his email says, currently, I am interested in computing the rank of certain semi-randomly produced matrix. With Macaulay, this is a computer algebra package specialized in especially algebraic geometry. The command output for singular will return a prime number and a double list of numbers representing the entries of the desired matrix, so how I can read this matrix. Here, G is an even number, a genus, say 8, 10, 12, 14, and N, a number greater than 2 with 2 and 3, blah, blah, for the interesting cases. While the case G equals 8 runs in seconds, G equals 16 took 16 days in Macaulay. And he actually wants to compute bigger examples, going on to 18 and 24 and so on. So the next day, I had only recently wrote Python wrappers for this linear algebra library called FLAS and FFPAC. This does exactly linear algebra over finite fields. And when I tried his examples, I said I could compute the rank for G equals 14 in 10 seconds. And after some struggle to read the input format, which actually lasted a lot longer than the computation, the matrix for G16, which Macaulay took 2 weeks, 16 days, Sage did in 11 minutes. So using the right tool really matters, and you want all these libraries to be available and usable. Sage is very nice because everything is packaged in there, and you can just write Python wrappers and access the underlying functionality. But from other packages, this is not very easy, especially since, so these are the timings if you want to see, and the matrix sizes are not actually that big. If you want to use this FLAS or FFPAC, it's included in this library called Limbox, developed in Grenoble mainly. And it has a lot of dependencies. And most of these things don't come with regular distributions. So Givaro, NTL packages exist because a lot of things these days depend on NTL, but NTL is getting outdated. So in order to install Limbox, you need to handle all this. And Empire is a fork of GMP, so you could say that GMP works. But the rest, Atlas is present, GSL might be present. Installing these is hard because they are templated C++ libraries, and then you need to handle the paths. And this is well beyond the skills of a regular mathematician, algebraic geometer, or someone like that. Another example, this is not from mine, but this is quite a while ago. This is 2007. Maybe you know the online database of integer sequences. Its creator, Neil Sloan, once asked on the developer list for Paris, this is a number theory package. So he wanted to install Paris on his Mac, and he couldn't manage to do this through Think or any of the Mac packaging mechanisms. And in the end, John Cremona said, why don't you just install Sage? Sage includes Paris, so you will have Paris with Sage. And it worked. He wrote, I would like to thank everyone who responded to my question about installing Paris on an iMac. The consensus was that it would be simplest to install Sage, which includes Paris and many other things. I tried this and it worked. Thanks. It is such a shock when things actually work. So if you want to know what Pari depends on, Pari is a reasonably small specialized number theory package written in C. It only needs readline and Empire, which is GMP. So you can find these in many places. It's not that hard to install. And in order to do that, he installed Sage. This is the dependency graph for the packages installed in Sage. It has 93 vertices. Sage is a huge beast. So in order to get that small thing, he needed all this. So in order to solve this problem, many mathematicians or generic scientific software developers have invented their own custom-built systems, which so writing a simple package manager is not that hard. You unpack the sources, build, and then install in some directory, and you set the path right, statically link so they don't collide with anything. But it's a lot of effort. It's a lot of duplicated effort. And you end up building the basic libraries like GMP or NTL several times. And of course, when there is an update to one of the underlying libraries, actually everybody who uses it has to update their own package, which includes the dependencies. So the idea of a distribution is really needed here. And there are a lot of examples of these. These are specialized mathematics software. Probably you have never heard of them. I have to work with them almost every day. So the solution is actually to use, well, the distribution tools that we already know of and provide a solution to mainly mathematical software, because this is my motivation, but of course it works for any scientific software setting. What do we want? We want a customizable distribution of mathematical software, which will let us install packages, keep track of the dependencies and conflicts. This is what your distribution package manager normally does, not rocket science. But it would be good to use the compiler and tools on the host system, because duplicating everything and creating so Donny mentioned that on his Mac he has a Gentoo. This Gentoo includes its own compiler and everything. It's a bit big. You don't want to set up a whole distribution just because you want to install this Pari. And it should be able to do this without administrative rights, because you want to, so I have a lot of access to powerful computers, but I don't have root on them. So I can't install any software I want. I need to police the system administrator, and if you need a lot of different versions, then it doesn't go quite well. I just want to be able to do everything in my home directory. This is the main goal, but if we can have more, why not? It would be good if the other goals come mainly from this Sage, because Sage manages to do these things and it really helps. It should also be able to set up a development environment for supported packages. This is mainly motivated by the fact that many mathematicians may not be able to write a whole package with its build system and utility functions and everything, but they know their stuff well. And if they stare at 100 or 500 lines of code, they will be able to find what is wrong with it, if there is something to fix, or how to optimize it better. If the system handles the rest of the stuff, then they can improve the existing packages. But it would be very hard to get them to learn about Git or auto tools or libtool, all of these things. And based on the development environment, if they made changes, then they should be able to share it with their colleagues so that this gets around, and the improvements can be distributed everywhere. And how do we do this? All the tools to do this already exist, so it's just a matter of putting them together in the right way to make them useful. And there is an example of how this is done in Sage, but it's not as flexible. So this is like a generalization of the Sage packaging system. I will talk about Sage also later. So the architecture is based mainly on Gentoo, because I use Gentoo for many years. I'm a huge fan, and I really like the flexibility that I can configure everything to my wishes. So that is the main motivation. There you have the use variables, which let you toggle if you want a certain option in a package. For example, I work with a group developing this commutative algebra software called Singular, and it has interfaces to all these new systems now. polymake and gfan and all these. And you don't normally want to have all of them because you don't have polymake on your machine. That's another big thing. But if you can turn this on and off, it would be great. And of course, Gentoo also provides this functionality that it can support multiple compilers. You can switch which linear algebra library you use. So it comes with lots of bells and whistles that would be useful in the everyday life of a scientific software developer user. Gentoo is very developer friendly because if you've installed a package on Gentoo, since it built it from source, you know that you have all the developer headers and everything. So if you want to compile software, everything is already there. There are no dev packages, and there is support for live e-builds. This means that Gentoo can pull sources from CVS, it used to be, it started with, but now Git, Mercurial, and compile it and leave it there. And whenever you want to update this package, it will fetch the latest version. So this is very useful, especially in terms of the developer functionality that I mentioned before. If you want to get the latest version and stare at a piece of the code, Gentoo does most of the work for you. Its package format is very simple because it's shell scripts, basically. But it's very powerful because it handles a lot of the error checking. So we saw the dies you don't need anymore. And there is a lot of quality assurance going in the background so that once you write your e-builds, but you write the files in a different location where they shouldn't be, or it overwrites a file, the package manager portage will tell you. And you don't screw up so easily. And this is very important because, again, a mathematician creating a package will probably not care so much on, if it collides with something, or is the file really in the right place? Shouldn't it be somewhere else? Or did I mark this executable mistakenly or something? And if the package manager can do all of this checking for you, then it's great. And the standardization process that was mentioned is great because it means that somebody really thought about the package mechanism and how the commands should work. And there was real discussion going on instead of the developers one night decided that, oops, we need this command, and came up with something in the middle of the night, which doesn't quite work. It is a relatively clean format for the complexity of the task. So I said writing a package manager is a simple task. You just unpack the sources, build them. But once you really want to build a lot of packages, there are all these small tweaks that you need to do, and these are hard, and then it gets complicated and complicated. And in the Gentoo e-builds, as it was mentioned, there is also support for the prefix environment, which means that you can install Gentoo in your home directory on macOS or FreeBSD, Solaris, even Windows. And the e-builds, most of them, already contain information on how to do this. One of the examples Donny showed actually had, if the host is Interix, do this, which means it's, Windows-like platform, the Unix tools for Windows. Or if it is Solaris, do this. So this knowledge is already embedded in there. You don't need to rework all of these details. I should have mentioned one disadvantage I see with prefix is the need to install all of the tool chain and scripts and everything. So if you even need to, you install the scripts to start an SSH server and things like this, if you install those, it's too much. We don't need them. So besides Gentoo prefix and the beauty of Gentoo, there is also the Gentoo science project, which amazed me quite a lot when I was looking at the repository, because they have very specialized mathematics software already in the repository. There is really a lot, I'm sure. So I have no familiarity with biology and all these fields, but there is a lot, and this is great because most of the effort actually goes into packaging in this business, not writing a package manager, which is what many people concentrate on. And as I said, I have been a Sage developer for many years now, 6, I think, and maybe longer. So Sage contains about 9, actually it's 100 something. The graph didn't contain some of the basic ones that is required for bootstrapping. All of these packages, which are not in the Gentoo Science repository, are in another overlay. This is a custom package repository in Gentoo speak. It's a bit like the Ubuntu personal package archives, but of course it's a bunch of e-builds. So there is already a project to create e-builds out of the packages in Sage. So if I want Sage on my Gentoo machine, I don't need to rely on the Sage distribution, which even wants to install a compiler of its own, you can just take the Gentoo e-builds and then install it from there, which will have all the advantages of the quality assurance and so on. So also, if I want to base my project on these, then it really reduces the need to create new packages. There are a couple of more things added to the Gentoo mixture. So that is all created by other people. There is this tool called Compiler Wrapper, which was originally written by Volker Braun. He's a Sage developer as well. And this wraps GCC. And in the background, it parses the arguments, changes them so that you have the library paths and you can enforce relative linking. This means that you don't need to set the library path or LD library path arguments to, well, first compile and then run the software that you have compiled, because it knows where the libraries already are. And of course, if you want to relocate your compiled binaries, the relative linking really helps, because then you don't need to go through all the binary files and rewrite the path inside them. So this is some part of the magic. I install compiler wrapper and make that handle most of the compiling as soon as possible. The whole process is driven. So initially, you need to get a system where the package manager will work. And until that point, you need to write a lot of scripts, basically. Gentoo prefix has a script for this. It's called Bootstrap. It even has, well, colorful lines, and it's partly interactive these days. Can do most of it for you. Since I don't like shell scripts or writing makefiles or autoconf, auto tools things so much, I use WAF, which is a Python-based build system. Wonderful. It comes as a single file, which is actually compressed data. And it handles all the dependency checking and installing the missing programs that you need to get the package manager and the rest of the Lemonade system into action. Besides this, I need to modify. So yes, there is prefix support and it does everything, but of course prefix is still, it assumes that it has all the Gentoo tools available and it's in a relatively comfortable environment. I have to modify some of the e-classes and e-builds to actually not have these assumptions. So there are a bunch of e-classes and e-builds that are customized, or some code is commented out, some code is added to actually work in this prefix-like environment where you have to rely on the compiler and stuff on the host. And of course, there are a couple of specialized math software that I need, which were added there, or other people need. And they should find their way into the Psi overlay in the near future, I hope. I am not very good at using Git to push things through the overlay. This is mainly how Lemonade tries to work. So there is the underlying operating system. And on the operating system, you have your GCC and the basic libraries and Fortran and core utils and all these things. And above this, you want to create a compatibility layer, like a uniform environment where you can then use the Gentoo tools or the Gentoo prefix packages. So above the operating system, I say that there is a plain flavor of Lemonade, which creates this compatibility layer for you. This is also called bootstrapping in, well, distribution talk, where you install the missing parts. So if the distribution does not have bash and the stuff that Portage needs, I should actually maybe switch here. So Portage is quite heavy in itself. It wants to have a lot of things available. But then, if you're going to develop anything, then you want to have these available anyway. So I don't think it's so harmful. So in order to get Portage to work, you need bash wget or something to fetch things with. It also supports others, of course, and also GNU versions of sed, awk, and core utils, and etc. So on a system like FreeBSD or OSX, you need to install these things first before you can even think about using Portage. So the plain flavor checks what is necessary and installs them. And after the uniform environment is set up, you can just use Portage or the general Gentoo commands, or I don't think the other package managers actually support prefix that well, but maybe other package managers like Paludis or pkgconfig to install whatever you want afterwards. And the steps that I perform to get this running is basically, so the goal is to get Portage working in this hostile environment. So as I said, there is this bootstrap script from prefix, which can install many of these packages. So the WAF script, which is like an auto-tools script, it's like an auto-configure, checks what is missing, and calls bootstrap to install whatever is necessary, whatever is this set. And after that, it calls the prefix bootstrap, Gentoo prefix bootstrap script to bootstrap a copy of Portage. But so this is all done manually. There is no e-build used. It's simple shell scripts installing what is necessary. After this stage, we can actually use Portage to install packages, and then it will populate its database and hash the files it's installing, keep track of the file system and everything. So after this stage, it's not bootstrapping anymore. It's actually emerge. This is the command that is used. So after this stage, we have to emerge compiler wrapper, which is the magic that overrides the GCC arguments, and auto tools. So I delay installing things as much as possible. If there is a version of auto tools that works, then we don't need to bootstrap it in the beginning. And after this stage, it is OK to actually emerge Portage itself. So you need to repeat it because Portage needs to know that it is installing its own files. You could probably hack the Portage database and write the data there manually, but this is simple and it works better. After this stage, you need to make sure that it is a Gentoo-like environment where you can install packages. And also, so there is the prefix also creates this shell environment where all the variables are set for you. So you want to actually create the base layout with the bash profile scripts and everything. So for this, we have the base layout dash prefix package, which we emerge. And then you just set up the start script, which sets the paths, as I mentioned, and this is it. After this point, you can enter that shell, or you can manually call. So you don't, as I said, you don't need LD library path or anything. So you can also just call the emerge binary directly, and it will be able to install what you want. And so Portage also embeds most of these things in its config variables, so it knows about the new root of the directory and which user you are and all these things. For example, as I mentioned, there are these mathematics packages called poly. This is the polymorph. It's something in convex geometry. If you want to count how many integer points there are in a polyhedron or something like this, then you use this. It's written in an extended version of Perl, quite horrific, but. And there's the singular commutative algebra, and Sage is the huge distribution and the Python library that has a lot of functionality. If you want to use these things together, all you need to do is, so this is just the Gentoo commands. In Gentoo prefix, you can just write local start prefix. This is the script that sets your environment. And if you want to enable the polymake option in singular, you just say use polymake, emerge singular. It will just work. And this is Gentoo. So there is a singular e-build, which knows about how to set the configure parameter that will build this callable library. And of course, when you do this, all the dependencies, including polymake, its Perl modules that it depends on, or the latest versions of MPFR, Empire, and all these things, will be installed. So it does all the dependency tracking and everything, just one command. There is an interface in the other way, but this is highly experimental, so you need to do more command line, I don't know. So there was this thing to say that there was a lot of effort to make the command line interface of emerge as user-friendly as possible. But of course, as user-friendly as possible still does not satisfy the requirements of regular mathematicians. I don't think anybody would want to type this themselves. This means just overwrite the config files in the system without worrying, and make me use the latest experimental version of this package, and then just install it. So I plan to have a wrapper script which will actually handle this without having people deal with emerge in the command line directly. And what do I mean by a development environment? It's actually a live build. but instead of, so live builds usually download the source inside the regular directory where they also download the source tarballs for other packages. This is configured to, okay, not on this slide. This is configured to put the slide in the devel directory of the root of your Lemonade environment. And under that directory, it doesn't do the regular. So a live build normally checks out the repository, exports it like you would create a tarball, and does the build there. So the repository is clean and you can update without doing any harm. Normally, when you are working, and since many packages do not support out of 3 builds or anything, you just check out into that directory and you do the configure make install there. So I modify the classes handling the live builds to actually do this instead of export and do a very clean sandbox build and then install that onto the system. And if you want to get the Pynac is a C++ library which uses Python objects for numbers. It's based on GNAC, which was developed in Mainz long ago. This is the basis of symbolic computation in Sage normally. So if you want to get the sources and set up an environment where you can hack on it, you just need to type this. And this is mainly to just enable, so this version is masked, and it means please install this highly experimental thing for me. Okay, so this is what I will say on the functionality of Lemonade mainly. Now I plan to compare what other alternatives there are and why I chose to go this way instead of that way. So the other build systems that I've looked at, or that exist that I know of, the Sage build system is what I have worked with so many years, and it's very simple. I will talk about this, and it was the main motivation behind this all. It does a lot of things, but unfortunately, it's not very extendable. And then there are all the custom-made scripts. Python has a lot of distribution options, and there is even ongoing work and lots of funding actually on ongoing work to solve this problem in the Python area. There's Homebrew. And of course, a lot of people in the scientific community create live CDs or virtual machines where you can have the software. This is also what Sage does. So there are binary images for major distributions like Ubuntu and Fedora, but there's a virtual machine if you want to use it under Windows, or if you want quick access, there is also a live CD where you can try it out. I don't think these are really good options, and I will come to that. And then there are some, there's the Nixos, maybe most of you know anyway, and a neat idea called CDE. Let's start with Sage packages. Sage package is called KG, Sage package, and it has the preset directory structure. So there is an SRC directory which contains the original sources in expanded form. But of course, there is no way to verify that they are actually the original sources that correspond to that package. And then there's a directory called patches, which contains a bunch of diff files that are applied in the course of the build. There are 2 scripts written in Bash. One of them is called spkg install. This is just a shell script that goes into the SRC directory and does the configure make install or whatever else is necessary. But of course, it isn't. So there is no checks, or there are no you really write everything by hand, and you need to check error conditions and everything, and fail gracefully by writing an error message if one of the steps failed. spkg check came afterwards. It allows you to test the build. And the metadata is stored in a text file, but there is no standard format. You just write a list of changes, and you say this package depends on a few others. It's super simple. And it works. And a lot of people, everybody can create these packages. Sage, as I said, already contains about 100 packages, and it can work on a lot of platforms. But there is a huge build farm that covers Solaris and Itanium machines and everything. But maintaining this is very hard, because in order to update the package, you just extract the tarball, you replace the sources, you check each of the patches, and it's horrible. And there is no quality assurance. You just twist your fingers and hope that it will work. Of course, it's very well tested on a build farm, and that adds a lot, but it's still not everything. So as I say, standard packages are very well tested because there are also a lot of users trying this out. But optional packages usually do not work because nobody ever built them anywhere. The dependencies for the packages are tracked in a makefile. If you want to add your own package or if you want to fix something, this is not very easy to do by yourself. You need to look through this mess. And these things do not respect any C flags or anything. So you really wish that everything will work. And if you want to add a debug argument, you need to extract everything and add a command line parameter, which is, again, not easy. Customization is done through environment variables. These are usually have a prefix of Sage. And you can set, for example, for Atlas, I want this architecture, and it will give you the right optimized linear algebra packages. But these are not, well, you need to document them in a central repository, and it's hard to keep track of all these things. But apart from all these difficulties, Sage is great because it knows how to, when you install Sage, there is already an environment where you can develop the main Python library code. You can get into this directory and you see the code. It's already a Mercurial repository. Make your changes. There are actually, Sage uses an IPython shell normally. So without getting into the command line at all, after editing a file in here, you can export a patch and then upload it to the track server without using Mercurial yourself at all. It handles all of this. And also there's a web application front end to Sage. It's also set up in this environment. And if you want to, Python, of course, does not need to be compiled, but Sage has this Python compiled language. It compiles Python and annotations to C. So if you need that, you need to do the sage-b, and it will go into this directory and redo all the build. So this is great if you are working on Sage. But of course, it's not great if you want to develop a component of Sage, like if you fixed a part of Paris or Singular, then you can't use any of this. You actually need to extract the tarball, reach into the source there. And there are actually a lot of questions of users coming in and saying, so how does Sage do factorization? Well, Sage calls Paris. But where is the code for that? Well, you need to go to the Paris website and find their source there. So this only works if you're in Sage. And the logic to set up this environment is hard-coded for these scripts. So you cannot easily make your package set up one of these for yourself. So you can't have devel Pynac here. OK, so as I said, Sage is not very extendable. Now, about specialized distributions and live CDs and USBs, there is, of course, a lot of effort to create scientific versions of Linux distributions, which host a lot of packages. But, I don't want, so not all mathematicians want to use Gentoo. If you use Gentoo, then, of course, you have all these things, well, most of these things already available to you. And it's great, but if I create a live Gentoo CD with all the scientific packages, then people will not want to have the desktop set up by Gentoo or the wireless connections being set up by whatever. So even when I have to use a different distribution, like, I don't know, Ubuntu, Unity, or whatever, it's really disturbing. I like my desktop configurations. I like the system part of the distribution to do its job, and the scientific packages can be done by something else. So I don't want to use a distribution only because it has a couple of scientific packages. Something else, so Gentoo satisfies the rest of the criteria, of course, but some other distributions do not really provide the rapid release cycle that you might need to get bug fixes to the users. If you want to, you just fixed something small and you need to upload it to a server where then users update, etc. This is a very long cycle. If you push one line change in an e-build, and then they have to just pull the Git repository and call update, this is very simple. And it's not easy to support binary modules and things like this in different package managers. And of course, development environment or live e-builds are usually not an option. Specialized distributions are great if you want to try something for 10 minutes, but if you spend most of your time developing scientific software, then you will have to use that distribution for, well, forever. And I like to choose my own distribution. OK, so the section about neat ideas. This is not really, so CDE is a lightweight application virtualization tool. This is not really a distribution, but it does a lot of magic that comes up in, well, sharing code and also in the open science and reproducible research discussions. If you write a Python package or just a C program and you want to share this with your colleague, CDE allows you to type CDE and then the command that you would use to run this program. It basically uses strace in the background and keeps track of what binaries in the system were used in this process. And then takes those binaries, creates them, copies all of them in a prefixed environment and makes it work there. You can tar that up, send it to your colleague, and it will work. It's great magic. But this does not really answer the question. So we want to do software development together. If you want to share a small piece of code, it works great. But in the long term, it doesn't really solve the problem, because in reproducible research, you actually need to document how to reproduce it. It's not just, you should be able to run the program. This is not reproducing research. And of course, there are so it has a lot of magic and it works, but there are technical problems. For example, if the kernel binary interface changes, then it can't do anything about this. Or you, of course, keep track of one computation where the binaries are listed there, but if you give another input, other files might be used. So it doesn't know about these. And the last slide, Nix. I don't know how many people have heard of Nix. OK. Nix is a purely functional manager. It came out of a PhD thesis of, well, a computer science PhD thesis, of course. And there is also a Nixos project based around this functional package manager, and it's great. It redefines the file system hierarchy altogether, and it lets you build packages side by side. It can support multiple users on the same system. Non-root users can install packages, in theory. And it supports atomic upgrades and rollbacks. So if your upgrade at some stage goes wrong, it can roll back to a previous configuration because of the functional design. And it also has this continuous integration system, which can, it's in the University of Ghent, I think, build the packages and test them all the time. It's a great idea, and it has promise, but it has a few problems. So the file system hierarchy in Nix is very different, because it takes each package, puts it in its own directory, and then you need to know exactly which other package it depends on. It creates a hash based on this dependency and forces unique installations of everything. If you want to take care of reverse dependencies, so for instance, your package depends on a simpler thing, and that was updated, even if the binary interface is updated in normal Linux distribution, if the binary interface is the same, in normal Linux distributions, you don't need to do anything. But in Nix, because of these unique hash requirements, you need to recompile everything that depends on this. So many people criticize Gentoo for the need to compile everything. Here, you need to compile even more. And since the file system hierarchy is redefined altogether, you need to really take care. You specify all your dependencies and everything. But OK, if you're packaging something, of course, you should do a clean package. But if I am just writing software because I need to compute something, I don't want to really worry about all these details. I want to get my job done. This is also the argument for using languages like Python, where you don't need to declare your types beforehand. And the package database does not contain many mathematics packages. This was one of the main reasons that I did not go with this option. There are similar projects that use the Nix-like idea, but not all the hash and the unique directories. So Global Linux rootless distribution also redefines the directory structure to put every package in a separate directory. I think EasyBuild also does this, but I've never tried that. OK, so for a conclusion, to go back to the linear algebra problem, as I said, the G16 case was easy. It took 11 minutes. The G18 case also worked. And this was later written up in a paper. The next interesting case happens to be the genus for 24 case, where the matrix has a huge size. And if you want to use Limbox to compute this, it will be 94 years of CPU time. But in the meantime, I came upon other libraries that could be able to do this. There is this Kado NFS, which is a number field sieve implementation. So if you ever keep track of prime records or factorization records, some of these are computed with this package, also developed, well, mainly developed in Nancy. The linear algebra code, so number field sieve needs linear algebra, especially over the field with 2 elements. But so after extending that linear algebra code, it needs about 3 CPU years, and this code is completely parallel. So if anybody has a spare cluster, then this would be a project. And going back to Lemonade. So new algorithms are created from existing building blocks, and we want the fastest libraries that provide these building blocks on our hands when we are doing things. And we want to reuse code instead of rewriting. So this will reduce development time, and more users is always good. And the current distribution methods do not really satisfy the rapid release and customization and optimization requirements that we have. So Lemonade gives you a software distribution which will make your packages accessible, and a development platform where you can actually access the sources of, well, selected packages and change things there. Also, it's a uniform platform where you can just access the linear algebra and basic functionality that you might need, and you can share your code. It enables researchers to build on existing tools without fear of losing users to baffling installation instructions, which not many can cope with, and concentrate on specialized reusable libraries while taking advantage of testing and distribution tools. So I didn't talk about those. Available only in large monolithic systems like Sage and so on. List of contributors up to date in chronological order. Of course, the Gentoo developers have done the most contribution, and I can't name them all. Sage on Gentoo was the project that wrote most of the packages that I daily rely on. And apart from François Bisset, who's in Canterbury, New Zealand, Christopher Schwann in Mainz, and Steve Trogdon are the main contributors there. And these are the other people who have helped me, mostly from Kaiserslautern and some other places as well. So, questions?
Hi, I'm sorry I missed the first part, so probably this question is not a good one. In a nutshell, Lemonade uses the Gentoo prefix system.
Yes.
But simplifies a bit, so with the...
It takes out the system. Exactly. So Gentoo has this system set, which includes the compiler and all the basic libraries, toolchain, and so on. It takes out that part.
But for example, if imagine that you install, say, a simple Debian system,
yes,
which doesn't have any GCC installed by default.
You need the compiler.
You need the compiler, okay.
Yes. So my thinking in that case was that if you need to install the compiler, then you might as well install prefix.
Okay, okay. Thank you. Can Lemonade use the binary packages of Gentoo? So if you build a binary package, if you create the binary package, can you
It's very hard to distribute software in binary form. So in theory it can, but once you install the binary, it's not guaranteed that it will work because the binary compatibility is very flaky. But
you can just re-emerge it later, and if it doesn't work with the binary, you can just re-emerge it. And
you can compile from source, yes. But so I am thinking that maybe based on the Unix idea of unique hashes for capturing the state, we can add to the Gentoo binary package mechanism this unique hash that will give you working binary packages for Gentoo, which will also solve my problem.